This video shows you how we make ions. So ions are charged particles. There are two types of ions. There are positive ions and negative ions. And we make these ions by atoms either gaining or losing electrons. So before we look at positive and negative ions, if we remind ourselves, so we've mentioned the term atoms here. Now an atom, remember, is a neutral particle. An atom contains 3 subatomic particles, protons, neutrons and electrons. But it contains protons and electrons, which are the positive charge and the negative charge, in equal amounts. Therefore, they cancel each other out, which means overall the atom is neutral. What then happens is, if you've got an atom that's neutral because it's got the same number of positive particles as negative particles, if you start to lose or gain those negative particles, then you alter that ratio. There's no longer an equal number of positive and negative, therefore we have made what's called an ion. So if we consider the positive ion first of all. Positive ions are when you have metal atoms. So if we look here, we've got all these metal atoms. The example I have here is calcium. So calcium is atomic number 20. The atomic number of 20 tells us it has 20 protons in its nucleus. We then look at the number of electrons here. So we've got 4 different energy levels. When we add up those numbers there, 2, 8, 8, 2, that means that it also has 20 electrons. That's what we'd expect. This shows us the electron arrangement for an atom of calcium. So when we're asked about calcium, the calcium atom has got the electron arrangement 2, 8, 8, 2. It's a neutral atom. It has got 20 protons and also 20 electrons. But what happens is, every one of these atoms, remember, wants to be like a noble gas. The noble gases are the ones to be, right? And the reason for that is that they have a full outer energy level. They're what we term as being stable. They have a stable electron arrangement. They don't need to form bonds with anybody. They don't need to lose or gain electrons. They've got exactly what everybody else wants to have. And when we look at metals here, so calcium, to become like a noble gas, calcium would either have to lose those 2 electrons at the end, or it would have to gain more to give itself a stable outer energy level. So what metal atoms do is they lose their outermost electrons. So this calcium is going to lose its 2 electrons. So calcium here loses those 2 electrons, and its electron arrangement now becomes 2, 8, 8. It's lost 2 electrons. It's no longer an atom. It's an ion because it's got less electrons and protons. It's got 2 less electrons. It's given those 2 electrons away. So the calcium ion now has a 2 positive charge. It's given away 2 of the negatives, so it's now got 2 more positives and negatives. So the symbol for the calcium ion is 2+. So when we look at metal ions are always positive. And the size of their positive charge is determined by how many of those outer electrons they gave away. So if we look at aluminium here, for example, atomic number 13. Atomic number 13 and its electron arrangement of 283. So the aluminium atom is 283. And if I'm looking at what the aluminium ion would be, then I know it's going to have the symbol Al, but because it's an ion, I'm looking for some charge up here. So at the moment, the aluminium atom has got the same number of electrons as protons, but to become stable, it's a metal atom, it's going to lose that last number. It's going to lose 3 electrons. If I've given away 3 negatives, that means I've now got 3 more positives than I have negatives, so I'm a 3+ ion. The negative ions. So when we look at the negative ions here, negative ions are made when you have non-metal atoms and non-metal atoms gain electrons. By gaining electrons, they now have more negatives than positives, so they become negatively charged. So we have a chlorine atom here, and a chlorine atom, we see in group number 7 is 287. So it's element number 17, 287. Now for it to become stable, for it to become like a noble gas, it's easier for it to become like argon by gaining 1 electron than losing 7 to become like neon. So we gain 1 electron. So what happens is the chlorine is 287. To become stable, we want to add an electron in. That means I've now got my stable electron arrangement. Great, that's what I was looking for. I'm now an ion. But the one thing we notice about non-metals is that the last bit of their name changes. You don't get a chlorine ion. You get a chloride ion. Okay? And the chloride ion, it's still the same symbol. It's still chlorine, so it's still Cl. But I've now gained an electron. I've gained a 1 negative charge. I've now got 1 more negative than I have positive. Sulfur. So again, the sulfur atom. So if I look at the sulfur atom, sulfur is number 16. And its electron arrangement is 286. It's a non-metal, so I'm 286. It's a non-metal, so I'm going to have to gain electrons to become stable. Again, I need to have 8 in here. So this time, I'm going to add 2 electrons in. So to add 2 electrons gives me my 288 electron arrangement. I've now become an ion, and again, this ending in my name, you don't get a sulfur ion, you get a sulfide ion. It's sulfur, so it's still the symbol S. I'm an ion now though, so because I'm an ion, I must have a negative charge, and the size of my negative charge is how many electrons I had to gain, so I had to gain 2. So to make ions, to make negative ions, you make negative ions when non-metal atoms gain electrons. The number of electrons they gain to become stable tells me the size of the charge that they have. And the last thing to remember about the non-metal ions is that we must change the ending of their name to IDE. Your positive ions are made when non-metal atoms lose electrons. And again, the number of electrons they lose gives you the size of that positive charge.